Good morning Year 7 and welcome to today's maths lesson. Let's start off with a quick starter, shall we? Can you solve x minus 2 equals 11? Can you then find for me what 3/5 of 35 might be? And I think of a number, let's call it x, I double it and then I subtract 5. Can you write that as an algebraic expression for me? Okay, pause the video and in your light blue books have a go at these questions now, please. Right, that first question, I want to find out what x is on its own. So to do that, I need to add 2 to both sides. Adding 2 to both sides tells me that x on its own is equal to what, Brooke? 13. Excellent, thank you very much. I want to find 3/5 of 35. To find 1/5 of 35, I need to divide it by what, Lucy? 5, great. So 1/5 is going to be 7. But I don't want 1/5, I want 3/5. So 3/5 is 7 times 3, which will give me 21. And my last question, I said I think of a number x. There it is. I double it, so I need to put a 2 in front. And then I subtract 5. So as an algebraic expression, it's going to look like this. Okay, Year 7, this is our lesson destination for today. Questions like these. But let's start off by working out what a regular polygon might be. On the board are 2 examples and non-examples. On the left, I've got an example of a regular polygon. And on the right, I've got a non-example of a regular polygon. So this one here is a regular polygon, and this one on the right-hand side isn't. Have a little think. What do you reckon a regular polygon therefore has to have? Poppy, what do you reckon a regular polygon has to have? Equal sides, exactly. A regular polygon has to have equal sides to be regular. So the rectangle, which doesn't have equal length sides, is not a regular polygon. Here we go, I've got 2 more examples. What do you reckon a regular polygon has to have? This one's an example, this one's a non-example. Again, it's equal sides. The equilateral triangle on the left-hand side is a regular polygon, all the sides are equal, and the isosceles isn't a regular polygon because those sides are not equal. Right, now I've got 2 shapes where all the sides are equal on both sides. However, the one on the left is a regular polygon, but the one on the right isn't a regular polygon. Have a little think. What do you reckon a regular polygon has to have? Right then, what do you think a regular polygon has to have if the one on the left is and the one on the right isn't? Equal angles, exactly. A regular polygon must have equal sides and equal angles. So how about now? This one here's got equal sides, this one here's got equal sides. Are the angles equal? What's a characteristic of a regular polygon? Rosie, what do you reckon? Again, equal angles, perfect. The one on the left, the octagon's got equal angles and equal sides. The star has got some equal angles. This one's equal, this one's equal, this one's equal, this one's equal, and this one's equal. But it's got some other angles which aren't equal. Here they are. So that's not a regular polygon. Okay, Year 7, in your dark blue books, in the middle of your page, can you write regular polygon? And can you give me what you think a definition of a regular polygon might be? Some characteristics, some examples and some non-examples. Be as creative as you like. Pause the video for 5 minutes and have a go at that now, please. Okay, this is what I came up with. I said a polygon has got sides that are all equal sized and interior angles that are all equal sized. I said characteristics, again it's got to be connected with straight lines, all sides have got to be equal, all angles have got to be equal, and I've drawn some examples and some non-examples. Yours might look slightly different. Make sure you've got something written in your dark blue books. Okay, cast your minds back to our last lesson. We said the sum of the interior angles in a polygon was equal to what? Barbara, can you remember what the formula was? N minus 2 times 180? Bang on, Barbara. Where n is the number of sides of the polygon. So if I ask you, what is the sum of the interior angles in an octagon? Can you pause the video and in your light blue books, can you tell me, is it A, is it B, is it C, or is it D? Okay, let's go through the answers. So the sum is equal to n minus 2 times 180. In this case, I've got 8 sides to an octagon, so I'm looking at 8 minus 2 times 180, which gives me 6 times 180. 6 multiplied by 180 gives me 1080. So the answer I was looking for was D. Here we go. This time I've got a slightly irregular polygon. 1, 2, 3, 4, 5, 6, 7-sided. Can you pause the video and in your light blue books, can you tell me what's the missing angle? Pause the video and have a go at that now. Sorry, I said 7-sided, I meant 6-sided. Okay, let's work it out. So the sum this time is going to be 6 minus 2 times 180. So the sum of all those interior angles is 4 times 180. 4 times 180 will give me 720. So I know the total of every single one of those angles is going to be 720. I need to work out what the question mark is. So the question mark is 720, take away all those other angles. So 720, take away 150, take away 110, take away another 110, take away 90, take away 140, gone off the screen. So the question mark in this case is going to be what, Jack? $120? Lovely. Is that an option? Yes, it is. Make that a bit clearer. So the answer I was looking for was B. Okay, let's voyage into some new territory. We know the sum of the interior angles was n minus 2 times 180. I've been asked to calculate the size of an interior angle in a regular octagon. Evie, what does a regular octagon mean? What does that word regular mean when we talked about regular polygons? Exactly, all the angles are the same and all the sides are the same. So we know the sum of the interior angles is going to be n is 8, so we've got 8 minus 2 times 180. So the sum of all those interior angles is 6 times 180, which is 1080. But we've been asked to find the size of one of the interior angles. We know there are 8 equal interior angles within a regular octagon. So if the sum of those 8 equal ones is 1080, to work out one interior angle, we need to do 1080 divided by 8. The sum of them is 1080. We need to divide it by 8 to work out what one of them would be. 1080 divided by 8 is 135. So each of those angles within that octagon is going to be 135 degrees. There we go. Let's check. If I did 135 plus 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 135, that would give me 1080, so it works. Over to you. Can you, in your dark blue books, have a go at this one for me? Can you find the size of an interior angle in a regular pentagon? Pause the video, in your dark blue books, have a go at that now, please. Okay, let's go through the answer. This time the sum is going to be 5 take away 2 times 180. So the sum of those interior angles is 3 times 180. 3 times 180 would give me 540. But this time I've got 1, 2, 3, 4, 5 of them. So I need to do 540 divided by 5 to work out individual angles, which leaves me with 108 degrees. So each of those individual angles is 108 degrees. Can you make sure you've got this example in your dark blue book for me? Pause the video if you need to. And then in your light blue book, can you have a go at filling out this table? I filled in some of the parts for you. Can you work out the name of what that polygon might be, the number of angles within it, the sum of what those interior angles might be, and the size of one interior angle in a regular polygon? Pause the video and have a go at those questions now, please. And these are the answers. Please check your work and see how you did. Okay, one final type of question you're going to come across. So pens down and eyes on the boards. I'm going to go through an example and then you're going to do an example. These are a little bit trickier, so we're going to go slowly. The sum of the interior angles is n-2 times 180. Always has been, still is. I've been told the interior angle is 120 degrees. How many sides does the polygon have? So n is the letter we've given to the number of sides. I know that 120 multiplied by n, whatever n may be, is the sum of the interior angles. So I know that however many interior angles there are, if there were 3, I've got 3 times 120 would give me my sum, or 4 times 120, or 5 times, whatever n might be. I also know that the sum of my interior angles is n-2 times 180, using the formula at the top. So I know that 120 times the number of angles, or the number of sides within my polygon, will give me the sum of the interior angles. And I also know that n-2 times 180 will also give me the sum of the interior angles using the formula above. So I know that 120 times n must be equal to n-2 times 180, putting those two formulae together. I'm going to expand that bracket. 180n take away 360. I'm then going to solve it by adding 360 to both sides. Subtracting 120n from both sides. So the number of sides by dividing both sides by 60 tells me that 6 is equal to n. Let's go through that slowly one more time. So if the interior angle of any kind of polygon is 120, how many sides does it have? If n is the number of sides, we know that the total of all the interior angles within that polygon has got to be 120 times the number of sides, or 120 times the number of angles within it. We also know from our formula above that the sum of the interior angles was n minus 2 times 180. I then put these together. I said that 120 times n has got to be equal to n minus 2 times 180 because the sum of the interior angles is equal to the sum of the interior angles. I expanded that bracket. I said that 120n is equal to 180n, take away 360, as 2 times 180 gives me 360. My next step was to get rid of that negative 360 by adding 360 to both sides. My next step was to subtract 120n from both sides, because I want n on one side and numbers on the other. And my final step was to divide by 60 to work out what n was. So my polygon must have 6 sides. Over to you, Year 7. In your dark blue books, if the interior angle is 156 degrees, how many sides does the polygon have? Use my example to work it out. Pause the video for a couple of minutes and see what you can do. Okay, let's go through the answer. So n is the number of sides, or the number of angles, within the polygon. We know that in this case 156 multiplied by the number of angles will give me the sum of the interior angles. We also know that n minus 2 times 180 will also give me the sum of the interior angles. So we now know that 156 times n is equal to n minus 2 times 180, just putting those two equations together. So 156n is equal to 180n, take away 360. Let's solve it in the same way. 156n plus 360 gives me 180n. Subtracting 156n from both sides tells me that 360 is equal to 24n. Dividing both sides by 24 tells me that in this case n is equal to 15. So my polygon in this case has got 15 equal sides. Please make sure you've got this example in your dark blue book. This is tricky, take it slow and check your answer as you go. Okay, Year 7, in your light blue books, can you have a go at these examples for me? There's just 3 examples up there. Use your dark blue notes to help you go through it step by step. And if you're confident, can you have a go at my extension question? Pause the video for 10 to 15 minutes and have a go at these questions now, please. Okay, let's look at the answers. I was looking for 15 sides, 12 sides and 36 sides. Just put that back for the people that are printing the questions off. And here are the answers to my extension question. Well done if you got that right. I was looking for 40 degrees using angles on a straight line. And the number of sides of the polygon should have been 9. And finally, Year 7, this was our lesson destination today. Green was the easiest question. Please have a go at this in your light blue books. The yellows are slightly harder. Have a go at those for me. And if you're confident, have a go at the red question in the bottom right hand corner. Pause the video for a few minutes and have a go at those in your light blue book now. And these are the answers I was looking for. That's the end of today's lesson. Can you now head over to Google Classroom and complete the exit ticket I've posted there. Well done today and best of luck.